All right. We are being asked to find the sine and the cosine function of this graph right here. Now, this is a sinusoidal function, and it's not at all what it should look like if we know what sine and cosine looks like. So let's do the sine first and hope that when I do the cosine part, a lot of things repeat. Here's a hint, it will. This is what I know sine looks like. Okay, this is what I know sine looks like. I know sine starts at 0, 0. It peaks out at 1, it bottoms out at -1, and it repeats itself every 2 pi. So peaks out at 1, bottoms out at -1, and repeats at 2 pi. We don't have that. We don't have that at all. So what I'm going to do is I'm going to look at this picture and try to figure out where the starting point would be and go from there. So if I were to start halfway in between the top and the bottom, where it starts to curve up, where it starts to be concave down, it looks like a good starting point would be right there. So now what I'm also going to do is write out the general forms for a sinusoidal function when using sine. Okay, that form is y equals a times sine, where I'm multiplying inside b times x minus c, close it, plus d. A is the amplitude. Okay, pretty easy to find, generally speaking. B is the frequency. I'm going to have to do a little bit of math. C is going to be a phase shift, which means horizontal, which means left and right. Keep in mind, whenever you're dealing with stuff inside the x part of the parentheses, everything is backwards. And then you have plus d. And d is going to be a vertical shift, just like it seems to always be whenever we deal with adding stuff outside the parentheses. So let's see what we have first. Let's start out with the amplitude, because that's usually the easiest to find. The amplitude is found by doing the very maximum and the very minimum, so A. Now taking that maximum number, which is 2, minus the minimum number, which is 0, subtracting that and dividing it by 2. The amplitude is not the top minus the bottom, and it's the size of the whole thing. It's half of the whole thing. So that's where we kind of get this average-looking formula from. 2 minus 0 is 2. 2 over 2 is 1. So the amplitude is 1, which means life is easy. I don't have to write that really difficult number. B is found by doing the frequency, which in order to do the frequency, I need the period. Now, the period is where this wave process repeats. So what we need to do is we need to find an obvious spot where this repeats. So it looks like the very top of the wave and the very top of the wave happen here. So the period can be found, that's not how you spell period. The period can be found by doing this right side here, which is 5 pi over 2 minus the left side minus 7 pi over 2. So we have a double negative, make it positive. 5 pi plus 7 pi is 12 pi. 12 pi over 2 is 6 pi. Now, does that mean b is 6 pi? No, no, no. You find b by taking 2 pi and dividing your period. 2 pi divided by 6 pi's, pi's cancel out, b is a third. Okay? There you have it. Now, what I have here is my starting point is now this guy right here. That's kind of like my new origin. How do I get to that new origin? Well, I have a positive phase shift. I'm moving to the right what appears to be pi. So when you move to the right what appears to be pi, what you're actually doing is you're doing x minus pi. Remember, when you move to the right, it's the opposite of what it appears to be. So my parentheses is going to be x minus pi. The way that you find d is found by doing the midline, which I kind of already created, but let me write it out a little bit further. The midline is the horizontal line that cuts my wave in complete halves. Wherever that goes through, whatever y value that horizontal line is going to be your midline, which is going to be your d. So in this case, d is 1. Now I have enough information to put all of my sine stuff together. Y is going to equal an amplitude of 1, which is invisible 1, don't need it, sine. My B is a third, parentheses, x minus pi, because it's right 3, close it, and my D is positive 1 because I shifted up 1. That's my sine. Now I need to find my cosine. And if you're like, oh no, I have to start over. Nope, because with the cosine, the amplitude will be the same, the midline will be the same, and the period and the frequency will be the same. So the only thing that changes is this guy right here. So let's kind of get rid of you. You're now dead to me. I don't need this picture anymore. And I'm going to rewrite this equation and sneak the word cosine in there if I can make it look pretty enough, and I just did. So cosine. All right? What does cosine look like? Well, cosine starts up here at 1, goes through half a pi, bottoms out at -1 at pi, and then repeats itself at 2 pi. Okay, repeats itself at 2 pi. So where can I find a peak to start at? How about here? That is a peak that I can start at. Okay, so how can I get to that guy there? Well, I can get there by going right 5 pi over 2. Now, if you're confused and if you're wondering, well, couldn't I use that guy right there? I sure could. The nice thing about periodic functions is they repeat themselves, and so it doesn't really matter which peak that I choose, so I'm choosing this one right here, 5 pi over 2. So 5 pi over 2 is the only difference that this is going to be. So everything else is going to stay exactly the same, but since I'm phase shifting right positive 5 pi over 2, that is going to be x minus 5 pi over 2. These guys stay exactly the same, except for this guy, and now I'm calling it cos. So y equals the amplitude of 1, so invisible 1, cosine, my frequency didn't change because my period didn't change, x minus 5 pi over 2, that's the only thing that did change. My midline didn't change, so it's still plus 1. And there you have it, sine and cosine functions. You can't spell functions without fun, and that's what this was. So like and subscribe.